The homework that we want to check over from last night is worksheet number 17, refraction. The answers are up on the board there. Okay, take a look at those answers and make sure that you've got the right answers, or at least you know which ones you have the wrong answers for. Once you've done that, there's going to be a list of questions that I'm selecting this time to go over, just that seems to be representative of the questions that we have on this page. So basically, we're going to try to do one of each type of question. Then if you're struggling with some of the other ones, then you can try them again. If you still can't get the right answer, then you can ask me tomorrow. Take a quick look. And after you've done that, we'll go over question 2 and 3. We'll go over 6 and 8. And we'll go over question number 10. Again, if you had any of the other ones wrong, then try them again after we've gone over these questions and see if you can figure out what you've done wrong based on what we've done as we go over them. First question that we want to do is question number 2 on worksheet number 17. It says, calculate the speed of light in diamond. Now, there's a couple of ways that we can do this. The easiest way is to go back to the definition of index of refraction. The index of refraction is the ratio of the speed of light in a vacuum to the speed of light in medium X. So we can write that as an equation. N is equal to C over V. That means the speed of light in diamond is equal to the speed of light in a vacuum divided by the index of refraction of diamond. Let's just say 3 times 10 to the 8 divided by the index of refraction of diamond, which is right on the sheet that I gave you. We solve for that. It works out to be 1.24 times 10 to the 8 meters per second. Now, we get a speed that's dramatically slower than the speed of light in a vacuum. We should expect that. We get a number that's higher than 3 times 10 to the 8, then we know that we've done it wrong. We know it has to be less than, and quite a bit less than, because we've got a high index of refraction here. Yep, Micah. Will we ever have to use this one where it can't be replaced by the other one? No. You can always go back to that other equation. Micah, let's do this question using the other equation, the Snell's law equation here. Say V1 over V2 equals N2 over N1. Now, the trick with this is you need 2 media. You need 2 different materials, and we don't really have 2 different materials in question number 2. So what we can do if we want to use Snell's law is assume air. We want to find the speed of light in diamond. Well, it's going from air to diamond. If that was the case, then we'd say 3 times 10 to the 8, that's the speed of light in air, V1, divided by V2, equals the index of refraction of diamond, which is 2.42, over, we assumed the index of refraction, we assumed the first medium to be air. That's over 1.00. When we solve that, we still end up getting 1.24 times 10 to the 8. Now, technically, you could do this with question number 2 and assume the other material was anything you wanted. But the only problem is we don't know the speed of light in the other materials. We don't know what V1 is if we pick something other than air. So that's why we picked air or a vacuum there. Question 3 says a ray of light passes from air into water. Let's draw this out here. Ray of light passes from air into water. Okay, we want to determine the speed of light in the water. First of all, we know that the index of refraction of air is 1.00, and the index of refraction for water, which is on that table again, is 1.33. Because the index of refraction increases, what's going to happen to the speed of the wave as it goes into this new medium? Speed up, slow down. As you go from a low to a higher index of refraction, the light slows down. And as the light slows down, it means V gets smaller, theta gets smaller as well. Theta 1 ends up being bigger than theta 2 because it's decreased in speed. Let's say V1 over V2 equals N2 over N1. V1 is the speed of light in air. That's medium 1, 3 times 10 to the 8. We're trying to find V2, the speed of light in water. N2 is the index of refraction for water. It's 1.33. And N1 is the index of refraction for air, 1.00. Solve for V2 there. Bring V2 up by multiplying, and then 1.33 down by dividing. And V2 works out to be 2.26 times 10 to the 8 meters per second. Again, Should the speed of light in water be smaller than the speed of light in air? Yes. We've got a smaller value here, although it's still 10 to the 8 meters per second, which it always should be, but low enough that it seems like a reasonable answer for us. Let's take a look at the next one that we had picked to go over here, number 6. When light passes from water to quartz glass, it refracts at an angle of 25 degrees. What's the angle of incidence? There's my boundary again. It goes from water to quartz glass. It's coming in at an angle, let's say, of whatever. We don't know what its value is, but we'll draw it like this. It's refracting at an angle of 25 degrees. Can you tell me whether it's going to speed up or slow down as it goes from water to quartz glass? The index of refraction for water is 1.33, and for quartz glass, I believe it's 1.52. Sorry, 1.47. Is it going to speed up or is it going to slow down? Going to slow down. As you go from a low to a high index of refraction, it slows down. If it slows down, then theta is going to get smaller as well. So it's going to bend toward the normal line. It's going to look like this. Now we know the value of theta 2 already. It's 25 degrees. We should expect when we solve for theta 1 for it to be a bigger value than 25 degrees. How much bigger? Not sure. But we should expect to get a value that's somewhat bigger than 25 degrees. Let's say sine theta 1 over sine theta 2 equals n2 over n1. We're looking for theta 1. N2 is 1.47. And N1 for water is 1.33. Let's take that 1.47, divide it by 1.33. Let's get the value for sine 25 and take it up by multiplying. And then let's take the inverse sine of whatever that number is, and we should end up getting 27.8 degrees. Is that a number that's bigger than 25? Yeah, not much, but it's bigger. The difference in the index of refraction isn't all that much, right? 1.33 to 1.47. So we should probably expect to get an angle that's bigger for theta 1, but not all that much bigger because the index of refraction isn't all that much smaller. 27.8 degrees. Number 8. That's my favorite one that we're going over here today. Determine the ratio of the speed of light in crown glass to the speed of light in quartz glass. If you remember back last unit or the unit before, I can't remember, we had to find a ratio. We had to compare two numbers, find a ratio. And we said whenever you're asked to do that, you divide the two numbers. The ratio of my age to your age. Right? We said 40 divided by 16 is 2.5. The ratio is 2.5 to 1. When we want to find a ratio, we always divide the two numbers. If we want to find the ratio of the speed of light in crown glass to the speed of light in quartz glass, then we're going to divide the speed in crown divided by the speed in quartz. Now, if we were asked to find the ratio of quartz glass to crown glass, we'd divide it the other way around. Whichever one comes first goes on the top. Now, if we know the numbers for the speed of light in each of those materials, then put them in and solve it. You can solve for the speed of light in each of those materials using the definition for the index of refraction. N is equal to C over V. But there's an easier, quicker way. If V1 over V2 is equal to N2 over N1, then VC over VQ is equal to NQ over NC. We know the indices of refraction. The index of refraction for quartz glass is 1.47. And for crown glass, it's 1.52. So let's not divide the two speeds, which we don't actually have. Let's divide the two indices of refraction, which we do have. When we get the ratio of there, works out to be 0.967. So the ratio of NQ to NC, or you could say the ratio of VC to VQ, which is really what we're looking for here, is 0.967 to 1. So there's two things to catch here. One, When you're asked to find a ratio, divide. 2, you don't have either of those numbers, then come up with an expression that's the same as those two numbers. Okay, we don't have V1 over V2. Well, V1 over V2 is equal to N2 over N1. So put those ones in instead. That works just the same. And finally, the last one that we want to go over here is question number 10. Determine the critical angle for zircon. When you have a ray of light coming in like this, if it exceeds the critical angle, then it's going to reflect. If it's smaller than the critical angle, then it's going to refract. If it's at the critical angle, it's basically in no man's land. The angle of refraction, theta 2, would be 90 degrees. So let's use Snell's law, sine theta 1 over sine theta 2 equals N2 over N1. We're going to convert theta 1 into theta c, the critical angle, and we're going to make theta 2 the angle of refraction at which the critical angle occurs, 90 degrees. Now, which medium is which? We're talking about zircon and air. One of them is 1.00, that's air. And zircon has an index of refraction of 1.92. Which one comes first? Are we going from air to zircon or zircon to air? We're not told in the question, so how do we know? Guess? Well, the beauty of it, Rob, is if you guess and you're wrong and you're looking for the critical angle, your calculator will actually give you an error. So your calculator will tell you that you're wrong. I'd rather you not have to guess, but if you do, guess. Okay, get an error in your calculator, then flip it around. Ideally, we just know how to do it right from the beginning. N2 is going to be 1.92, and N1 is going to be 1.00. Sorry, the other way around. The other way around. The reason for that is because we're always going from a high index of refraction to a low index of refraction. If we went the other way around, the ray of light wouldn't bend away from the normal line, it would bend toward the normal line, and we wouldn't get, under any circumstances, total internal reflection. It only happens going from high to low index of refraction. So N2's got to be 1, and 1's got to be 1.92. Now, I'm crossing that off. How come I was able to cross off that sine 90? Just make it disappear. Patrick? Good. Sine 90 is equal to 1. So that leaves me with theta c is equal to the inverse sine of 1 over 1.92. And when we do that, we get 31.4 degrees. So a fairly low critical angle. That means light is going to reflect fairly often. Therefore, if we have jewelry made of zircon, then you're going to get sparkling. But it's not as low of a critical angle as it is for diamond, as you saw in question 11, which means you're not going to get as much reflection, which means you're not going to get as much sparkling as you do with diamond. You comfortable with these? All right, we were supposed to have a quiz on this stuff today. Yeah, I made up a 5-question multiple choice quiz for you, but this morning's class had enough trouble with this worksheet that I decided just to postpone the quiz till tomorrow. We're going to do the same thing with you guys. Okay, quiz tomorrow on this. Try the other questions if you struggled with them. If you did and you can't get them tonight, then let me know, and we'll go over them during scheduled help tomorrow so that you're in good shape for your quiz tomorrow.